Hello guys, I am Akash. Welcome to Mechanical Words. This is the third lecture of Basic Thermodynamics. So let's start it. Today we will study in previous class we were studying the ideal gas law. Okay, so today ideal gas law. The ideal gas law is PV is equal to mRT. Here P is absolute pressure. P is absolute pressure. Okay. P is absolute pressure. V is volume. V is volume, and M is mass. V is volume, M is mass, and T is absolute temperature. T is absolute temperature. T is absolute temperature. Okay. So this formula is very important. Okay. So this formula is very important. You have to know. In previous class I was saying that the PV is equal to mRT has lot of applications in various numericals in thermodynamics. Okay, and you know that thermal engineering is is full of numericals. Okay, it has high weightage of numericals, so you have to understand this formula well. So let's study how this formula is coming. So that means the derivation of this formula. Okay, so let's start. Suppose ideal gas law derivation. Ideal gas law derivation. Ideal gas law derivation. According to Boyle's law, according to Boyle's law, V proportional to 1 upon P, where P and N is equal to constant. Okay. According to Charles law, according to Charles law, V is proportional to T, where P and N is equal to constant. Okay, this is according to Charles law. And then according to Avogadro's law, according to Avogadro's law, V is proportional to M. V is proportional to M, where pressure and temperature is constant. Okay, where pressure and temperature is constant. Okay. So this is okay. These three things there. Okay. So we will derive one by one with this ideal gas equation, ideal gas law. Okay. We will derive each law, like Avogadro's law, and then Charles law, and then Boyle's law. We will derive these three law with this ideal gas law. Okay, so then let's start. Let's go then. Boyle's law, derivation of Boyle's law. Okay, Boyle's law, derivation. अच्छा, one second. Derivation using ideal gas law. Ideal gas law. Derivation using ideal gas law. So first, Boyle's law. I hope you know that what is Boyle's law. Boyle's law. Boyle's law means P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Okay. So in this Boyle's law, we know that temperature and moles are constant. So these both moles by moles, temperature by temperature will cut out. Okay. So the final thing will come that P1 V1 is equal to P2 V2. Okay. P1 V1 is equal to P2 V2. So first derivation done. Then it comes to second one. Second one is Charles' law. Charles' law. Charles' law. Charles' law is here again P1 V1 by N1 T1 is equal to P2 V2 by N2 T2. Here pressure and mole constant. Okay, here pressure and moles are constant, so we will cut out this. Oh no, sorry, pressure and mole. No, pressure and mole. 1 second. Pressure and mole. P1 pressure and mole like this. Okay, these both are same. Pressure and moles are constant, so these both will cut out. So here the final thing V1 by T1 is equal to V2 by T2. Okay, so we are done with two law, and the third and last law is the Avogadro's law. Okay, Avogadro's law. So Avogadro's law. Avogadro's law. Avogadro's law, which is saying that P1 V1 by N1 T1, P2 V2 by N2 T2. Here temperature and pressure is constant. Okay, here temperature and pressure is constant like this. So V1 by T1 is equal to V2 by T2. Here V1 by T1 is equal to V2 by T2. Okay, V1 by T1 is equal to V2 by T2. So here the things is coming. Okay, so we are done with three laws. Okay, we derived three laws using ideal gas law. So I think already you have understood that how much important is this ideal gas law. Okay, we derived three laws, three important laws of thermodynamics, that is Charles law, Avogadro's law and Boyle's law, with this equation, ideal gas equation or ideal gas law. So that means you have already knew that how much important is this. Okay, so practice so many numericals on this formula, on this law. Okay, because in GATE or other competitive exams like bar, ISRO, here so much high weightage of thermodynamics carries. Okay, in bar, ISRO, especially in bar, there is so much importance of basic thermodynamics. Also, the interview board of bar will ask questions from thermodynamics to the to the employers. Okay, so you have to practice, you have to practice so much of questions from this topic. Okay, so let's begin. Okay, uh, let's go to the thermodynamic cycle. Let's go to the thermodynamic cycle. Okay, today we will practice questions. Okay, today we will practice questions, and next day in our next lecture we will practice only questions. Not we will not start, I will not teach you any theoretical part. In the next lecture we will practice so much of question, as much as we can, we will practice. Okay, so let's begin with thermodynamic cycle. Thermodynamic cycle. Okay, thermodynamic cycle means a circle. Thermodynamic cycle means a circle like this. Here is state 1, state 1 means this, and state 2, both in the single point. How? Because a circle has one starting point, and because the circle has same starting and ending point, so that's why the thermodynamic cycle states that the substances initial, in thermodynamic cycle, the substances initial state and final state is equal. Okay, in thermodynamic state, substances initial state and final state is equal. So that's his property. Okay, that's the property of thermodynamics cycle. Here we see that delta E of system, delta E of system is 0. Why? Because in this E in is equal to E out. Okay, E in is equal to E out, and so here we derive the actual part of the thermodynamic cycle. This is a basic form. Okay, the system of energy, the changing system of energy is 0, because its state 1 and state 2 is both same. The energy which is entering and the energy which is going out, they both are equal. That's why its changing energy of the system is 0. That's why it is that means the energy which is starting from here, okay, it's going, and again it is it's going out to this point. That means no energy difference is occurring. No energy difference is occurring. That's why the changing energy of the system remains 0 or becomes 0. That's the part. But if it in previous class we studied that if it going from this point to this point, okay, then its changing energy of the system will not be 0. Okay, because they both are different. The both, suppose this is point A and this is point B. So I think you already know that point A and point B is not equal. A and D, the both alphabets are different, then the both points will be different. So that's why the change in energy of the system will not be 0. Okay, so let's go to the derivation part. Okay, according to first law of thermodynamics. Okay, anyone knows what is the first law of thermodynamics? Anyone know? Anyone? What is the first law of thermodynamics? First law of thermodynamics is energy neither can be created nor can be destroyed. It can be transformed from one form to another form. Okay? It cannot be destroyed or it cannot be created, like our soul. Okay? Like our soul, it cannot be created, it cannot be destroyed, like light. Okay? It's only its state is like light energy. Its light energy is transforming from one form into another form. Okay. Suppose in solar electricity, we already know that light energy is transforming into electrical energy. So, okay. So this is how the total energy system of our universe is working. Okay. So according to first law, Q1 plus W is equal to Q2 plus W. Okay, this is W1, this is W2. Okay, so if we take Q1 minus Q2 is equal to W1 minus W2, then the Q net is equal to W net. Then the Q net will be equal to W net. Okay. So this is like, this is a circle, this is system, this is system, and this is Q1 which is entering into the system, and this is a work one which is the system is doing that one, and the Q2 which is going outside the work we were putting into the system. So both their difference, which is going, the heat which is going outside and the energy which is going outside and the energy we were putting in, their difference is same to the difference suppose to the difference, the work which is occurring in the system and what we were putting in the system, their difference is equal. So this equation is giving the information about the thermodynamic cycle. Okay, let's bye bye.